So I'm going to talk about dictionaries and sets in Python. And I'm running the code inside a Google Colab environment. In order to use this, you just need to have a Google account, and then you go to colab.research.google and then .google.com. Then you can write a code in Python. You can also explain your code with a text here, which is called Markdown. So before talking about the data structures dictionary and sets, let's review what was a list. Here we have a list. We have a sequence of numbers. It could be a sequence of strings or anything else defined between two square brackets. They are ordered. It means that this is the first one, this is the second one. They are zero based. It means that if we want to access the second member, we should have the index 1. So we refer to this with index 1. So with index 1, I got the second value of this list. But let's say I don't want to access the members of the set, which in our example are the daily temperatures of a week in a specific place. I don't want to access them with an index, but I want to access them with names of the days of the week, or access them in any other way, but not in sequential indices. Then in that case, I should use the data structure with the name dictionary. Why do we call it a dictionary? I will tell you later. So here I say, let's see, this is a copy of the values that we had on the top, but here I say that I want to access the first member with the index sun, that means Sunday. This is the temperature for Sunday. I want to access the second member with the index, with the key Monday. So this name or key functions acts the same way as the index works, but it has a meaning for human. So why do we call it a dictionary? Because also in a normal dictionary, you have a keyword and a definition, but in the language of Python, we call this a key and a value. The value of this key, sun, is 68.8. And just like the lists, we access the members with square brackets, but we don't put an index here, but the key. So you write the key when you want to define a dictionary, colon, and the value, key, value, key, colon, value. So let's see an example how that can simplify our work. Look, Sunday has the index 0. Saturday has the index 6 because the week has 7 days. Keep it in our mind is a bit difficult. So we want to see if Saturday was a warmer day or Sunday. If the first day of the week or the last day of the, Saturday or Sunday. If the first or last day of the week are warmer. Referring to them with the indices is a bit confusing, but with the names, no. We know that the weekend can be a Saturday or a Sunday. Then we compare the temperature of Sunday with the temperature of Saturday, and then we react based on it. So if the temperature of Sunday is bigger than the temperature of Saturday, then we print Sunday was warmer, the warmer weekend day. As a key, we can use any immutable data type. For example, here we have a tuple which has January the 2nd, 2004. We can use any such a thing, data type, as a key and give it a value. So the value for the key March 6th, 2000, the year 2000 is 68.2. So I accessed this key not with an index. I didn't use the index 1, but that means it is second value, but I used the key. This is a key, not an index. Yeah? You cannot get the value of this with an index because indices, numerical indices, are not defined for a dictionary. This is an example how our work would be difficult if we wanted to ask a user to enter a day name and get the temperature of it if we use two lists. So we have one list like this, which is the list of our values, the temperatures, and the list of our keys or the names of the days or virtually indices is here, and we have to translate. You see, we have to translate. I will share the link so that you can run the code. I don't want to stop here for longer time, but in short, using a dictionary in such a case that you have two lists which have one by one connection relation, and this relation is unique. Using a list is much more difficult than using a dictionary in which the connection or the relation is explicit. You can see it. So actually here we can consider this as two parallel lists which have the one-to-one relation. So if you visualize a dictionary, you may see such a thing, exactly the way we have defined a dictionary, like here. So let me run this. I just wanted to have the dictionary defined. So, and then if I show it, you will see key value pairs, key value, key value. And you can access the keys of a dictionary using the function keys, and the values of the dictionary using the function values. And they are functions, so you need to use this parentheses here. Then the keys, which are equivalent to our indices, are achieved this way, and the values are achieved this way by calling the function value of the object of the type dictionary. If you loop over a dictionary, you should be careful. This is a common mistake that many people do, and it's a surprise for them after they have learned that by looping over a list, they get the values of the list. When they see that when they loop over a dictionary, they don't get the values, but they get the keys. So these are the keys. These are not the values. See, when you loop over a dictionary, you get the keys. So we loop, we see, for key, this can be any other word. So So any other string could be used here, but I have written key just for clarity. When you loop over members of a dictionary, you will receive the keys, not the values. If you want to have the values, then you should find those values, refer to those values with the key, which is, I said, is equivalent to an index. So here I could simply write the values of dictionary in the positions of the key. So if you want to see that for each key which value we have, you can write key and then the value. The value is found by the key. So here you see that Sunday, I have to put this column here, you can put anything else. So Sunday, the key Sunday has the value 68.8, and the value is extracted from the dictionary by the key which has been Sunday, sun. So here we had a kind of definition of a dictionary that you saw, a kind of the definition of dictionary in which we know already before defining a dictionary which values and which keys will be inside the dictionary. But often while programming, you know that the data type is a dictionary, but you don't know that which values will come to the dictionary, and even how many of them will come to a dictionary. You can define a placeholder, that means an empty dictionary, this way, or even simply this way, and then use it later. Of course, here we are defining the dictionary in the air, that means there is no dictionary here, but let's say the name of our dictionary, our empty dictionary, is DC, and then we can later see what has been inside it. Or you can have instead of DC, you can dict, which is says that we want an object from the type or class dict. You can simply write DC is equal to these curly brackets, that is equal to what we have done here. That means here also we have created an empty dictionary. So this way you can make sure that the type is a dictionary. Now let's see if we can make a dictionary out of a two-dimensional list. That means we have pairs inside a list which are related to each other. For example, let's say this is a price. One apple is 66 cents, for example. We can cast, that means convert, this data type to a dictionary. So look, I ask the interpreter Python to convert the type of this list to a dictionary, and already automatically it gets the first value of an internal list, and considers it as a key, and the second one as value. And if you want to see how many pairs you have inside your dictionary, you use the function len. How can we add a value to our dictionary. Adding, like in lists, you would use the function append or extend, but in dictionaries, you simply so here I am finding a value of a key which is existing, but here I am defining a new key, and at the same time I'm initializing it. So here actually I am adding the key and value pair range and 0.22 to my dictionary. So before this line, the key value pair orange 0.22 did not exist. After that, we have it. And in order to delete a key value pair, you simply write del, del for delete, the name of the dictionary, and the key. You don't need a value. You just refer to that part of your dictionary. That means that member of your dictionary, the member of dictionary that you want to remove, to delete, and put a del on the left, and then it is deleted. You see that the bananas are not here anymore. So this was dictionary. Dictionary itself is one can understand it as a set, but let's do not make it confusing. Say we are done with dictionary, and now we are going to talk about sets. Sets are data structures which contain unordered and non-duplicate members. This is a mathematical concept. There is a branch of mathematics or a concept in the mathematics called set theory. For example, you have the set of natural numbers. Yeah? And here we have sets in Python, which tells us that in this data structure, which is also somehow comparable with a list, we have unique values that do not repeat themselves. So you cannot write 2 times 1 in this set. Even if you write in the background just one line, 1 will be saved in this set B or set A. Anyway, this notation is not a Python notation. It's just I'm defining that this is a set with the name A and the values 1, 2, 3. This is a set with the name B and values 3, 4, 5, 6. This is not the Python definition. Yeah? For Python definition that we will see later, you will just need this A is equal to curly brackets 1, 2, 3, and B is equal to curly brackets 3, 4, 5, 6. So we have 2 sets here. So as I said, set comes from set theory, from mathematics. This is a table for your information. Perhaps you may not need all of them, but it's good to know that they exist. For example, symmetric difference is rarely used. So let's review them. We have a membership operation in mathematics. We say 1 is a member of A. Is it correct? Yes. 1 is a member of set A. It is inside it. And in Python, we say 1 in A, which is 1 is inside A. And the answer is yes, it is true. We will practice these with Python coding. You can add a member to a set. In math, you write it like this. You take your original set, you do a union with a set, with another set which has just one member, and that member is what you want to add to your set. But in Python, you use the function add. So this function add adds the member, let's say, with the value 4 to our original set. If you want to remove a member from the set, in math you use this notation, a minus. In Python you use the function remove of the set class or set type. So here we added a 4 to our set, we got 1 2 3 4. Here we removed a 2 from our set and we got 1 3. Pay attention that we are not talking about indices, we are talking about values. We don't have indices in sets. You have union, which is somehow comparable with addition. So you take all values of these two sets and put them in a new set, and we say you have a unification. You have the union of these two sets, which is actually all the values of those two sets together. And in Python you can do this with a logical OR between A and B. You can see in which point the two sets have overlap, or are in which point of them is in common. Or in another language, what is the intersection of the two sets? So you have set A, set B, the intersection is value 3, is in common in both of them. In math you use it, you show it this way. In Python you use a logical AND. A logical AND. And if you Python, you have these two lists. Python, as a result of this intersection, will give you the value 3. You can also subtract one set from another set. The notation, the mathematical and Python notations are the same. What does this mean? It means that you take the first set, look which values of this is in the second set, remove them. So the value 3 of the set A is also in the set B, it appears also in the set B. So if you subtract this from this, just 1 and 2 remain. You see, 1 and 2 remain. A symmetric difference, it means that it's like union but without the common point. It means that you mix them together but remove the point of overlap, the point which is in common. And is shown like this. You take the union, it means the both sets together, except or having removed the members which are in common in both of them. You can achieve this with a hat between A and B in Python. And mathematical notation for the length of a set is this, and in Python you write len, the same as for the list and the same as for the dictionary. Let's see these in function. I have set A and set B. Set A has 1 2 3, set B has 3 4 5 and 6. You see 3 is in common. So let's see. I want to see if 1 is in set A. Yes, true, it is. I want to see if 5 is in set A. False, it is not. And then I want to see what will happen, or I want to remove the number 2 from my set. You see, I do not do a left assignment. I do not write set A is equal to remove. I just remove. And as a result, the original set is modified. So by running this, 2 is removed from set A. In order to keep this our set, I will add it back. And now let's see how does the intersection work. Of course, here is union, sorry. How does the union work? Union means the two sets together. It means that all members of the two sets together. I can achieve it by a logical or by the keyword union. So you take one of the sets, you call the function union of that set, and give the other set as an input to it. So this way you have added this to this, and as a result we have received the unification, the union of the two sets. It means everything inside them. Intersection or overlap, we said that we have the value 3 in common. So if you use a logical AND or the function intersection of the dictionary, then you can see the point of overlap, what is in common in both sets. So here 3 is in common. You want to see what is the difference between the two sets. So you say, I want to have set A, but I don't want to see anything in it which is also in set B. So that way the subtraction, the difference, will give you what you want. It means that you have to take the set A and calculate, find out the difference with set B. This difference of set A with set B, and the function difference is a function of the object with the name set A. So the function difference of the object set A is calculating the difference between the set A and set B. And with the symmetric difference, the same thing. You can put a hat here, and or you can put use the function symmetric difference to find the symmetric difference of the two methods. And you see, in order to show it later, to use it later, you have to use an assignment. And yeah, we said that in order to see how many members a set has, you use the function len. Sometimes in programming you limit yourself, you somehow forbid for yourself and other programmers to modify things. In languages like, for example, C++, you can, for example, define a variable as a constant. It means that no one can change it. And in Python, also there are some security, let's say security, safety mechanisms for programmers to limit themselves not to be able to do some things which are not supposed to be done. For example, you say an apple color, it can be red, yellow, or green. You don't have blue apple. So it's a fixed, limited set. Yeah. Such a set is defined this way: frozen set, and then you give a list as an input to the function or to the constructor of the class frozen set, or in another word, that you define a variable of the type frozen set with such values, you show it, and if you want to modify it, it will give you an error. This class even does not have the function add. Yes, that's it. I hope you enjoyed it.